There is a business district in southern China where dozens of towers, hotels, offices, and shopping malls stay comfortable through the worst of summer, and almost none of them are doing the cooling themselves. The work is being done by one enormous machine buried underneath the streets, and the people walking around above it have no idea it is down there. Today, we are counting down 8 ways China is cooling entire cities without relying on the air conditioners, And by the end of this, you will understand why the rest of the world is looking at heat completely wrong. Some of these are pure engineering. One of them is a paint that cools a building using nothing but physics and the emptiness of outer space. One of them is a trick that Chinese builders worked out 1,000 years ago, forgot about, and are now putting back into modern skyscrapers. And number 1 is small enough to sit in your pocket, cheap enough that almost anyone can buy one. And it might be doing more to keep people alive in extreme heat than anything else on this list. If you enjoy breakdowns like this one, hit that like button right now. These take a serious amount of research to put together, and every like genuinely helps more people find the channel. Subscribe and turn on notifications so you never miss what comes next. Let us count them down. Number 8, the outdoor air conditioner you have already seen. You have almost certainly scrolled past a clip of this without understanding what you were looking at. A packed shopping street in a Chinese city in the middle of summer. People eating, browsing, standing around, and hanging in the air above all of them. A thin white cloud that looks like fog decided to park itself over the sidewalk. Nobody underneath is wet. Nobody has an umbrella up. They just look far more relaxed than anyone has a right to be in that kind of heat. What you are looking at is an outdoor cooling system, and it runs on one of the oldest pieces of physics we know: evaporative cooling. Here is what is actually going on. Water is forced through nozzles that are so fine, the output barely counts as droplets. It comes out as a mist of particles so tiny that they never complete the journey to the pavement. They disappear into the hot air on the way down. And turning liquid water into vapor is not something the universe gives away for free. It takes energy, and that energy gets pulled straight out of the air surrounding each droplet. One droplet steals a tiny amount of heat. Millions of them over a busy intersection add up to something you can feel on your skin within minutes. These systems routinely pull the local temperature down by 5 to 8 degrees, not in a sealed room with the windows shut. Outdoors, in the open, in the one place where heat is normally something you just have to accept, and because the mist is so fine, it evaporates before it can land on anything. No puddles, no slippery tiles, no damp shirts, just cooler air where there was none. The part that actually matters, though, is the electricity bill. A conventional air conditioner has to squeeze a refrigerant, drive a heavy compressor, and wrestle with thermodynamics every second it is switched on. A misting array needs a pump and a water line. It draws a small fraction of the power. That means a city can cool a whole market, a transit hub, or a tourist square for a tiny share of what conventional cooling would cost. Assuming conventional cooling could even do the job, which it cannot, because you cannot put an air conditioner on an open street. And that is the thread running through everything on this list. Instead of asking how to manufacture more cold air, China keeps asking how to stop the heat from building up in the first place. Which brings us to a program that does not bother with the street at all. It goes after the sky. Number 7, making it rain on purpose. In the summer of 2022, China went through the longest and most severe heat wave in its recorded history. It ran past 60 days and shattered records that had been standing since national record-keeping started back in 1961. The Yangtze, one of the biggest rivers on the planet, dropped so low that stretches of riverbed cracked open in the sun. Hydropower stations in Sichuan, which push electricity to cities more than 1,000 kilometers away, fell to a fraction of their usual output. Factories were ordered to stop production. Fires started in the hills around Chongqing. So the government reached for an option that sounds like a plot point rather than a policy. It decided to make it rain. The program is called weather modification, and China operates the largest one in the world. The whole thing depends on a compound called silver iodide. Its crystal structure happens to look almost exactly like ice, close enough that when you push it into a cloud already carrying moisture, water vapor grabs onto it and starts freezing. Those crystals grow, get heavy, and drop. A cloud that would have floated over the city without giving up a single drop gets pushed into letting go. Getting that silver iodide up into the clouds is the dramatic part. China uses everything available: rockets launched from the ground, anti-aircraft guns firing rods roughly the size of a cigarette straight up into the atmosphere, aircraft flying directly into the cloud layer, and drones. During that 2022 emergency, a Wing-Lung drone, a large unmanned aircraft originally designed for military work, was sent up over the baked skies of Sichuan. In one flight lasting several hours, it burned through 20 silver iodide flame bars across thousands of square kilometers, pulling rain out of an atmosphere that had refused to give any up for weeks. After the seeding runs, temperatures in parts of the province dropped, and a few regions that had spent the summer desperate for water suddenly had to start preparing for flooding. Now let me be straight with you about the limits here, because they matter. Cloud seeding is not a thermostat for the sky. It only does anything when there is already moisture sitting up there waiting. Even under perfect conditions, the increase in rainfall is modest. Nobody is conjuring a thunderstorm out of a clear blue afternoon. What it can do is give a stubborn atmosphere the final nudge it needs. And rain falling on an overheated city does two jobs at the same time. It drops the air temperature immediately, and it puts water back into the reservoirs and rivers that every other system depends on. That is heat management operating at the scale of the sky itself. The next one did not come out of a research lab or a drone control room. It came out of a village that has been standing for centuries. Number 6, the 1,000-year-old skywell. Here's a question worth sitting with for a second. If builders 1,000 years ago could keep a house genuinely cool through a brutal, humid Chinese summer with no electricity, no fans, and no machinery of any kind, how did we manage to forget how they did it? Because we absolutely did forget. And architects in China are now going back and taking the technique for themselves. Step inside a traditional home in the old Huizhou region, and you will notice something strange sitting right in the middle of the building. Not a hall, not a living room, but a gap. A tall, narrow, enclosed courtyard that runs vertically through the center of the house and opens straight up to the sky. In Mandarin, it is called a tianjing, which translates as skywell. At a glance, it reads as decoration, a small pocket of light and weather in the heart of an otherwise closed building. It is not decoration. It is a cooling engine that runs on nothing but the behavior of air. Warm air rises. That is the entire mechanism. In a skywell house, the rooms wrapped around that central shaft stay shaded down at ground level, because the surrounding walls stop direct sunlight from ever reaching the bottom. The air down there stays cool and heavy. Any warm air that builds up in the house naturally floats upward and exits through the top of the well, exactly the way heat climbs a chimney. As it leaves, it drags cooler air in through the lower rooms to take its place. The building turns into a slow, silent ventilation system with no moving parts and no power bill. Just the shape of the structure doing the work. And the effect is measurable. Studies of these homes in southern China have recorded interiors running several degrees cooler than the air outside on a hot day. There are craftsmen who have spent more than 30 years restoring these buildings, formally recognized by the government as holders of an intangible cultural heritage. Specifically so, the knowledge does not disappear again. Here is where it stops being history. Engineers realized you do not actually need an open courtyard in the middle of your building to use the principle. What you need is the airflow. So, in Guangdong province, a 68-story tower was designed with internal channels running through it, essentially vertical windpipes moving air through a skyscraper, the same way a sky well moves it through a farmhouse. A 1,000-year-old idea scaled up, cooling floors that would otherwise be fully dependent on machines. The people who built those houses were not primitive. They solved a problem we later handed to a compressor, and then stopped thinking about entirely. Speaking of things we stopped thinking about, the next entry is a mistake baked into almost every city on Earth, including whichever one you are sitting in right now. Number 5. The streets are cooking your city. Next time you're outside on a hot day, look down. That black asphalt under your feet is quietly one of the main reasons your city feels like the inside of an oven, and hardly anybody ever thinks about it. Standard black asphalt is one of the most heat-absorbing materials we have ever deliberately spread across the surface of the planet. Its reflectance sits somewhere around 5 to 10%, which means the road is swallowing 90% or more of the solar energy landing on it. On a hot afternoon, that surface can push past 60 degrees Celsius, and in some places, well past 70. That is hot enough to burn skin on contact, but the road does not just get hot, it becomes a battery for heat. It charges all day in the sun, and then hours after sunset, when you are hoping for some relief, it keeps releasing that stored warmth back out into the night air. It is a huge part of why a city stays uncomfortably warm long after dark, while the countryside 20 minutes away has already cooled down. Scientists call this the urban heat island. Your city is genuinely a warm island sitting inside cooler surrounding land, and the road network is one of the main radiators keeping it glowing. So cities like Guangzhou and Shenzhen went straight at the source and started resurfacing roads with what are called cool pavements. There are a few approaches, and they are often stacked together. The first is solar reflective coatings. Rather than black, the surface gets treated so it throws a much larger share of the sun's energy back up into the atmosphere before it ever has the chance to become stored heat. The second is thermal blocking paint, which slows the road's ability to pull heat down into its deeper layers. And the third is highly porous material that holds onto moisture so the pavement can shed heat by evaporation. The same trick as the misting system back at number 8, except built directly into the ground you walk on. The results are not marginal. Field testing on these coatings has recorded road surface temperatures falling by roughly 7 to 14 degrees Celsius compared to ordinary asphalt sitting under the same sun. Now scale that across every major road in a large city, and you are not cooling a street. You're lowering the temperature of the entire heat island, and crucially, you're doing it overnight, which is exactly when it matters for anyone trying to sleep. Cooling the ground is one thing. The next entry cools the buildings themselves, using nothing but a coat of paint and the emptiness of deep space. Number 4, the paint that cools with no electricity. I told you there was something on this list that sounds like science fiction. And this is it. This is the one that makes people stop and ask you to explain it again. Because on first hearing, it sounds like it breaks a rule somewhere. It is a paint, that is all. You roll it onto a rooftop, and the building underneath gets cooler. No power supply, no wiring, no machine. And it carries on working while sitting in direct, punishing sunlight. So how does a passive coating with zero energy input make a surface colder than the air surrounding it? Because it is not fighting the heat at all. It is throwing the heat away off the planet. The technology is called passive radiative cooling, and it does two separate jobs at the same time. The first job is the one you would expect. The paint is engineered to reflect almost all incoming sunlight, so most of the sun's energy never gets absorbed by the roof in the first place. A very white, very reflective surface stays cooler. No surprise there. The second job is the clever one. Everything warm gives off heat as infrared radiation. Your body does it, the pavement does it, the building does it. Normally that radiated heat travels a short distance and gets absorbed by whatever is nearby, so in practice it goes nowhere at all. But there is one specific band of infrared wavelengths that our atmosphere is basically transparent to. Heat emitted at those exact wavelengths does not get caught. It travels straight up through the sky and keeps going out into deep space, which sits at a temperature close to absolute zero. This paint is tuned to release its heat precisely inside that band, which means a coated rooftop is quietly using the entire universe as a heat sink, dumping its warmth into space around the clock without drawing a single watt to do it. And because it can shed heat faster than the sun can deliver it, the surface can actually fall below the temperature of the surrounding air while the sun is still shining on it. That is the part that breaks people's intuition, and it is real. This is not a laboratory curiosity either. A team out of Hong Kong developed a commercial version, and the numbers are hard to argue with. On a rooftop in full sun, it has cut surface temperatures dramatically against an untreated roof and brought indoor temperatures down by around 10 degrees Celsius. The knock-on saving in cooling energy can approach 40%, simply because the air conditioning inside barely needs to switch on. It has already been applied across hundreds of projects in dozens of countries. A building that cools itself permanently for free by talking to outer space. That is number 4. Now we go from cooling one building to cooling an entire district from a single point. Number 3, the giant air conditioner buried under the city. Picture a dense business district, dozens of towers, offices, hotels, apartments, malls. Now picture the normal way we cool all of that. Thousands upon thousands of individual air conditioning units, each one bolted to a building, each one running its own compressor, each one holding its own refrigerant and pulling its own share of the grid. Every one of them fighting the same heat separately and burning energy doing it inefficiently. China looked at that arrangement and asked the obvious question: why cool a whole district with thousands of small machines when you could cool it with one very large one? That is district cooling, and in the Qianhai area of Shenzhen, it is operating at a scale that is honestly difficult to picture. Several floors below street level sits a plant that a journalist who toured it described as feeling less like a machine and more like a factory. Pipes, pumps, and industrial chillers filling a space you could fit a football field inside. It has exactly one function. It produces chilled water on an industrial scale, then pushes that cold water out through a network of insulated pipes running underneath the roads, feeding it into building after building across the district. Each tower connects to that network the same way your house connects to the water main. Cold water flows in, absorbs the heat inside the building, and flows back to the plant to be chilled again and sent out. Every building gets all the cooling it needs, and not a single one has to operate its own chiller. The entire district shares one enormous, ruthlessly optimized cold source, and the efficiency gains are where this stops being a convenience and starts being infrastructure. A system like this can cool close to 3 square kilometers of buildings. By collapsing all that scattered machinery into one properly engineered plant, the Qianhai network is reported to save around 130 million kilowatt-hours of electricity every single year. In terms you can actually feel, that is the equivalent of burning roughly 16,000 tons of coal. And it keeps something like 130,000 tons of carbon dioxide out of the atmosphere annually. Fewer machines also means far less refrigerant in circulation, which matters more than most people realize because refrigerants are some of the most aggressive greenhouse gases we manufacture. It is the exact opposite philosophy from the air conditioner. Instead of 10,000 small, wasteful battles against the heat, there is one enormous, efficient one happening underground where nobody ever sees it. That is the city-scale answer. But the last 2 entries are not about cities at all. They are about one person standing on a hot street with nowhere to go. Number 2, cooling the open air with sunlight. Everything we have covered so far cools something. A road, a rooftop, a district, a cloud. But none of it solves the situation most people are actually in on a brutal day. What about the person who is just outside? Walking, waiting, standing in the sun with no building to duck into? You cannot air condition the open air. That was the assumption anyway. So China started putting machines out there that attempt it regardless. At bus stops, transit stations, tourist areas, and busy public squares, you will now find standalone outdoor cooling units. Machines whose entire job is to push a stream of cool air out into open space, right where people are gathering, queuing, and sweating. Instead of walking somewhere to find relief, the relief comes to where you are standing. And here is the detail that turns this from wasteful into genuinely clever. A lot of these units run on solar panels. Sit with the logic of that for a moment. The hours when these coolers are needed most are the hours when the sun is at its most punishing, which happens to be precisely when the panels above them are producing the most power. Demand and supply rise and fall together, perfectly in step every single day. The heat making everyone miserable is the same heat running the machine that fights it. The sun stops being the enemy and becomes the power source. A bus stop that cools you while you wait, powered by the very sunlight making the wait unbearable, pulling little or nothing from the grid. Next to a district cooling plant, it sounds small, but it lands in the exact place where people actually live their day, in the ordinary minutes of standing around outside. Which brings us to number 1. Not a national program, not a piece of buried infrastructure. Something small enough to carry, so common in China now that it has quietly become one of the most widely used cooling devices anywhere on the planet. Number 1. The cooler you wear. Here is the twist. After drones seeding clouds, paint radiating heat into space, and industrial plants chilling entire districts from underground, the most effective thing on this list is also the smallest. It is personal, it is cheap, it is absolutely everywhere, and it is very likely saving more lives than anything else we have talked about. Walk down any Chinese street at the peak of summer, and once you know what to look for, you will see them constantly. A device curved around the back of someone's neck like a pair of headphones, quietly moving cool air across their skin. A handheld fan with a small water reservoir built in, throwing a fine mist into the airflow for an extra hit of evaporative chill. A jacket or vest with battery-powered fans sewn straight into the fabric, puffing up slightly as they push a continuous current of air across the body underneath. These are wearable air conditioners, and they have gone from novelty item to daily essential in China faster than almost anywhere on Earth. The neck coolers are the interesting ones. The good models do not just blow air at you, they press a metal plate against the back of your neck, and sitting behind that plate is a small solid-state cooling chip. Run current through it, and one side of it gets genuinely cold. Cold enough to pull heat directly out of your skin, at one of the few spots where your blood runs closest to the surface. Cool the blood at the neck, and you help cool the entire body. Chinese electronics brands have taken that idea and turned it into a mass consumer product, refining it year after year into something light, quiet, and surprisingly powerful for the money. And I want to finish on why this matters more than it appears to. We are used to thinking of a personal fan as a small comfort, a nice extra. But in a country living through record heat waves, where an enormous number of people work, commute, and spend their days outdoors in that heat, a device that keeps your core temperature inside a safe range while you are out on the street is not a gadget. Heat stroke is not an inconvenience. It kills people every summer. A cheap wearable cooler that an ordinary person can afford, carry, and switch on the moment conditions turn dangerous is a real line of defense for hundreds of millions of people. And it reaches them in a way no underground plant or reflective road ever could. That is the entire philosophy of this list, compressed into one object you can hold in your hand. China did not respond to extreme heat by building bigger air conditioners. It went after heat from every direction at once. From the sky with drones and silver iodide, from the ground with reflective pavement, from the rooftops with paint that dumps warmth into space, from beneath the streets with industrial chilled water, from the shape of the building itself, using a technique borrowed from architects who died centuries ago, and finally, right down at the level of one human being walking to work with a cooler around their neck. An air conditioner cools a room. China decided to cool the road, the building, the district, and the person, all at the same time. That is the real story here, and the idea underneath all 8 of these is worth holding on to. Most of the world still treats heat as a private problem, something you handle one sealed room at a time, behind your own front door, on your own electricity bill. China started treating it as public infrastructure, something a city plans and builds the way it plans roads, drainage, and water lines. That single shift in framing is what produced every entry on this list. Now I want to hear from you. Which of these would you actually want installed in your own city tomorrow? The mist that cools a whole street without leaving anyone wet? The paint that cools a building forever for free? Or the little cooler that sits around your neck? Drop it in the comments. If this changed the way you look at the road under your feet or the roof over your head, do the one thing that helps this channel more than anything else. Hit that like button, subscribe, and turn on the bell so the next one finds you. We will see you in the next video.